Direction of acceleration, part 1. In this tutorial, we'll see how to determine the direction of acceleration, whether it's positive or negative, using the example in figure 1.1.9. In this example, a person throws a ball, then catches it. Here in the first part, the ball is thrown upwards in this direction. Displacements, velocities, and accelerations in this direction are counted as positive in this example. In the other part, displacements, velocities, and acceleration in this direction are counted as negative in this example. And at point O, the ball is thrown from here. The graph shows the motion of a ball thrown upwards and falling back to Earth again to be caught. The ball starts from rest at time equals 0. The graph is a straight line with a positive slope between O and A. This is because the person throwing the ball gives it a uniform upwards acceleration between these 2 points. And we can see that the graph is a straight line with a negative slope between A and B. Between these points, the ball accelerates in a downward direction, which means it slows down at a steady rate, until it comes to rest at B, the highest point of its trajectory. Now, between B and C, the graph has the same slope as it did between A and B, but its velocity is increasingly negative. It is steadily accelerating downwards, which means it's speeding up. And we got to point C of the graph. At point C, the ball is caught, and between C and D, the graph has a large positive slope, as the person gives the ball a large upward acceleration to bring it back to rest. The direction of acceleration in the first part, we can see that it is acceleration. It has a positive slope, and between A and B, we have a negative slope, which means it's accelerating downwards. So the first part is an increasing straight line. Now notice how the slope of each part of the graph tells us about the acceleration of the ball, while the line itself shows us how the velocity of the ball changes. Now, since the area under the line represents the ball's displacement, we have here 2 areas, the triangle OAB and the triangle BCD. From the graph, we can see that they are equal, although area OAB is positive and area BCD is negative. So the ball's displacement upwards in a positive direction is equal to displacement downwards in a negative direction. In other words, the ball falls back to Earth the same distance as it rises and finishes up where it began. So if we get the area OAB and the area BCD, we would be getting the displacement of the ball. And the total displacement here is equal to 0 because area OAB and BCD are equal and they have opposite signs. One is positive and the other is negative.